In this video, we're going to learn how to solve two-step equations, check them, and then put them on their number lines. So with two-step inequalities, it's worked exactly the same way that we deal with equations, except for something at the very end, which I'll mention when we get there. So what we're going to do first, before anything, as always, you draw your great divide. So now, treat it exactly like an equation as far as solving goes. So we don't mess with the 2x, we mess with the minus 4. So remember to undo that. We add 4. Whatever we do to one side, we do to the other. The negative 4 and positive 4 cancel each other out. 2x is greater than or equal to. 2x is brought down. Greater than or equal to is brought down. And 8 plus 4 is 12. Just like with equations, we want to get one positive x by itself. So the two things are right next to each other, the number and the letter. So that means multiplication. So we're going to divide by 2 to undo it. Do the same thing over here. Now here's where the change happens. And this is where you need to be very careful with this. We bring down our x just like always. But now we have to bring down our inequality symbol too. This is where it differs from equations, and we're going to show that in just a second. 12 divided by 2 is 6. Now here's what this is saying. Before we go check, before we put on number lines, I want to explain what this x is greater than or equal to 6 means. This means we are going to have an infinite amount of answers. Had it been x equals 6, there's only one answer for that, 6. But here, would you agree that 7 is greater than 6? Yeah, that works. Is 60 greater than 6? Oh yeah, that works. Is 6 greater than or equal to 6? Yeah, that works. So notice as of right now, I have 3 right off the bat. You could probably think of more that would work. But here's something that will not work. Is 5 greater than or equal to 6? No. So 5 cannot be an answer. So anything less than 6 will not work for this. So here's what we do to check this. Checking your inequalities is super important, just like when we checked our equations. So pick a number. Anything x has to be greater than or equal to 6. So let's pick an easy one. Let's just say 8, okay? So where I'm going to say that x is 8. And everywhere we see an x, I'm going to plug in the number 8. So 2 times 8 minus 4 is greater than or equal to 8. We want to check this. So I have 16 minus 4 is greater than or equal to 8. 16 minus 4 is 12. And 12 is greater than 8. So this works. But I want to show you one more thing as well. This is just one check. You could have said, well, 10 is greater than 6. Plug it in. 2 times 10 minus 4 is greater than or equal to 8. 20 minus 4 is 16, and 16 is still greater than 8, and it works out. So notice I had many answers I could have chosen on this particular inequality, but that's the point. You must have the inequality in your answer. If you say this right here, this is a big no-no because you are saying there is only one answer. But with inequalities, there are multiple, infinite amount of answers. So the next thing I want to show you how to do is to graph this. So my equation is down here. I'm going to move this so where I can see my number line. My number line right here, it works a lot like how we did our number lines on equations. But I'm going to do one thing. I'm going to make it kind of simple. I'm just going to put one line right here and say 6. Okay? So here's how we graph this. Going back to the video over what the inequality symbols are, we have a greater than or equal to. So because of this equal to line underneath this, I am going to shade my dot in above x. Now the next thing we do, it is greater than. So greater than is always to the right. Think of it as adding greater. You're always getting bigger, so bigger is to the right. So I'm going to do my arrow this way. So let's check this with our answers. I picked 8 as an answer. Would you agree? 8, 7, 8. 8 is greater than 6, so it's included in my red line right here. I can pick 10 for that second answer. 10 is included on that line right there, so it is also part of our answer. So let's try one more just to make sure everyone's good. We got another one. In this problem, we have a x divided by 5 minus 9 is less than 2. So again, treat it exactly like we have with our equations. We draw our great divide. Now, x divided by 2. Remember we talked about this in one of our previous videos. You can either see it as x divided by 2 or 1/5 x. Either way, it's the same thing. So just kind of note that. So we're going to deal with that later, but we get rid of our integer first. So we have minus 9 or negative 9. So we're going to add 9 to undo it. Whatever we do to one side, we do the exact same thing to the other. The 9's cancel each other out. I'm going to bring down what's left, which is x divided by 5 is less than, so again, bring down that inequality. It's going to be super important. 2 plus 9 is 11. Now remember to undo division. So we've dealt with multiplication. To undo division, remember it looks like this fraction right here. We're going to multiply by 5. And we're going to multiply by 5 on the other side as well. The two 5's cancel each other out, which is exactly what I want. X is less than, bring down that inequality symbol, 11 times 5 is 55. So again, let me stress the difference. Had it been x equals 55, there is only one answer, and this is wrong. Remember, inequalities have many, 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 many answers. So to check, I'm going to pick an answer that is less than 55. I like 10 because 10's easy to work with. So I'm going to have 10 divided by 5 minus 9 is less than 2. So we're going to check that out. 10 divided by 5 is 2. Minus 9 has to be less than 2. Use your integer rules. So you're subtracting. So if you need to, remember with those integer rules, you can add the opposite and deal with your integers from the addition side, or you can use your number lines, whatever you need to do. So this is going to end up being 9 minus 2 is 7, and it's going to be negative because the 9's bigger than the 2. Negative 7 is less than positive 2. To show one more, just so that we're comfortable with it, we kind of know what we're doing, let's do 50 divided by 5, because 50 is less than 55. Minus 9 is less than 2. We're going to check that out. 50 divided by 5 is 10. Minus 9 is less than 2. 1 is less than 2, so it does work out. Now I want to show you one more. What if you picked a wrong number? Okay, so let's erase this real quick. Here's how you can check this in case you pick something wrong. Say you forgot your sign. Say you flipped it when you shouldn't have. Okay, so let's say you picked 100. Okay, so say you weren't reading your signs right. You were messing up your signs. 100 divided by 5 minus 9, is that less than 2? So 100 divided by 5 is 20. Minus 9 less than 2 is 9. So 20 minus 9 is 11. Is 11 less than 2? No, it is not. Therefore, you would have had a wrong answer had you gotten something like that. So kind of that's how you check it. Pretty easy stuff. So what we're going to do now is graph this on our number line. So remember, like I did on this first example, just going to graph a dot right here. I'm going to have 55 right here. Now here's the big kicker. Does this have an equal sign underneath it? No, it does not. So that means it is going to be an open circle, like that. And then because it is less than, think of the smaller, is to the left. So when I plug in my numbers, I plugged in 10. 10 was way over here. When I wanted to do 20, which was right here, that is less than 55 as well.